In this video, we're going to talk all about Python objects and gain a deep understanding of what exactly Python objects are. In Python, everything is an object, and it's crucial for you to understand what exactly these objects are in order to be able to use Python effectively. This video will help you if you're coming to Python from another language, you've been programming maybe for a few years, or if you've been using Python for a while, but you still feel like that you don't quite understand some of the things in Python, and it still doesn't feel really intuitive to you. It will also help you if you're just starting out as a programmer, and you've been doing programming for just a few months, and you've started with Python. And here's what we're going to do throughout the video. We will understand what exactly Python objects are. This is our main focus throughout the whole video. We'll try to answer this question as we keep moving forward. And as I said, it's a really important thing to understand. You've probably been told that Python is a really simple and easy language to use, but you might have tried it and you felt like that, hey, it's not as easy as people say. One of the reasons that you feel like that is probably because you don't understand what exactly Python objects are. So hopefully by the end of this video, you'll feel much more confident using Python in your software engineering career. Now also we're going to understand these core data structures in Python, these different object types, lists, tuples, sets, and dictionaries. They're really common in Python, you'll always end up using them, so we're going to really dig deep into them, and understanding them will also allow us to understand objects better. And also some of the characteristics that come with each object. An object could be mutable or not, or hashable or not, or iterable or not. We will also understand these other concepts. So each object in Python has some characteristics, and we're going to understand them in this video. And then at the end of the video, we're going to have 2 challenges to make sure that you understood everything correctly. And all the code that we're going to write in this video is hosted on GitHub. Alright, let's first start by asking a quick question. Right here, let me first create a folder. I'm just going to create a folder called UPCC, Understanding Python Core Concepts, and I'm going to navigate over into it. And right here, let's create another directory, and I'm just going to call it Objects, okay, because we are trying to understand Python objects. Now I'm going to navigate over into it, and I'm just going to open it up in my code editor like this. Now right here, I'm going to create one file. I'm going to call it app.py. And right here, let's ask our question. I'm going to create one list. So I'm going to call it myList equals. And here I'm going to put maybe 23 and then another list inside of that list. I'm going to put 1 and then 5 and then string hello. All right, so here's my question to you. How many objects do you think I am creating right now? So if I just go ahead and run my code, python app.py, how many objects did I just create right here? Did I create 1 object, 2, 3, 5, 6, 7, how many? So pause the video right now and think about this for a second. Alright, if you came up with 6, you are right. So I am creating 6 objects. Now the important thing in Python that we need to understand, one of the most important mentalities of Python is that everything is an object, okay? Now having said that, let's try to count and see how many objects we've got. So this whole list right here is its own object. So here's one. This 23 right here is another object. So here's another one. This list is another object inside of which it has another object of 1. So here's 2 more. 5 is another object, and this string hello is yet another object. So in total, 6 objects. Now, if this is not making a ton amount of sense to you, don't worry about it. By the end of this video, it's going to be 100% clear to you. But right now, I want you to understand that everything you've got in Python is just an object. And each object has its own characteristics. They all have some sort of framework that it can interact with. So right now, let's go ahead and talk about how each object in Python is represented. What are some of the things that you can do with each object, okay? It's a very important thing to understand. If you don't understand it, you will always struggle with Python. So let's get into it. All right, so let's take a look at a diagram. Here we can imagine that this is my memory. All these objects that you've got in Python are just sitting in your memory. And let's, as a convention, say that each one of these rounded rectangles that we're going to see, a green rounded rectangle is going to be an object in Python, okay? So right now I've got one of them on my screen, meaning that I have now 1 object in my Python code. Let's have this as a convention. Now let's see what each object has in Python. Now each object, first of all, it has a memory address because objects, again, are just sitting in your memory, and each one has its own address. Think of it like your home. You've got your home, and then you've got an address. You mention your address, and then you get into your home. Same thing here. You've got this object, you mention the address, and then you get into the actual container. Now we're going to look more into the memory address. This is an important one. If two objects have the same address, it means that they are the same thing, okay? Because each address is unique. Now, next up, for each object that you have in Python, you've got some methods and attributes associated with it. And you can easily call them and read their values. I've bulleted methods right here because mostly you've got methods. So if you create an object, and if you take a look at all the methods and attributes, you're going to see a whole bunch of methods and sometimes a few attributes. But they're mostly methods. Now, next up, you've got either some amount of data or some amount of instructions in your object. So if your object is a function or a method, as we have right here, again, methods for each object are also objects themselves. So if an object is a method or a function, for now we can just think of them like the same thing. So a method and a function are the same thing. If the object is a method, it's going to contain some amount of instructions. If it's not a method or function, it's going to hold some amount of data. So string hello, that string is some amount of data. Now, if the thing is instructions, now instructions are just some set of things that you can give to your CPU, and your CPU is going to just execute that. For example, adding a few numbers together, reading a file, or sending a network request. Some amount of instruction. As the name suggests, you are doing something. But data is just data, you're just holding it in your memory. So each object in Python could either have some amount of data or can hold some amount of instructions. And if it does hold some amount of instructions, you can just call your object and use parentheses to invoke it and to tell your CPU to execute those instructions. Now, the last thing that we need to understand is the type. So each object also has a type, maybe type string, type integer, or maybe a function. So the type is just going to tell us what is this object that we have. What is this item right here? Does this object hold maybe some numbers or maybe just one number? What exactly that thing is. All right, so this is an object in Python, and that's it. There's no really any sort of exceptions. Each object that you've got in Python has all these different characteristics. And you can take a look at all of them. It's pretty straightforward. You can create as many of these objects as you want. So you can just say something in your Python code and create one of these green things in your memory. That green thing is going to have some methods and attributes, address, data, and type. And you can also take a look at all of them and interact with them. So let's go ahead and take a look at this right now pretty quick. So I'm going to go into my terminal right now. So please just open up your terminal. I'm going to create a new tab. And I'm just going to go into my Python REPL. So I'm just going to say Python. So just open up your terminal, PowerShell, whatever it is. And in your terminal, type in Python. And this is just the Python process running in the background. Here we can put in some code, and Python is going to execute it and then output the result to you. So if I just say 2 plus maybe 1, it's going to tell me that this is 3. Okay. So here you can run Python code, you can create functions, you can create variables, and then as soon as you put something, it's going to tell you what that something is. So let's just create one object. So I'm going to say obj equals hello. I'm going to run it. And now what I did is that I just created one of those green boxes, and I can just reference it. I can just say obj, and it's going to tell me that this is object hello. Now you might be saying, hey, this is just some string. It's not actually an object. But again, remember, in Python, everything you've got is an object, and with each object comes the type, the method, and all of that stuff that we just talked about. So let's try to maybe see its type. Using the type function, you can pass an object to it. So you've got access to this type in Python, and you can just pass in an object to it, and it's going to tell you what is the type of that object. In this case, the type of this object is string, str, which stands for string. You can also see all the methods and attributes that I've got on this object by using the dir method. So I can say dir, pass in my object, and now you can see that I've got the list of all the methods and attributes that I've got available on this object. And we can call each one of them and do some operations on the data of the object. For example, let's take a look at this upper. So I can say obj.upper. It's a method, so I'm going to invoke it with parentheses. And when I run it, you can see that it's going to give me a new string hello. Notice that it did not change my object. We're going to talk more about this concept later on. But the thing is right now that you've got all these methods and attributes right now that you can just call and do some operations on the object. The object could have any other type and it's the same thing. Of course, the methods are going to be different, but still you've got some things like this that you can just call on each object. And each object type has its own set of methods and attributes. If this was any other string type, it would still have the upper, but if it was maybe an integer type and number, it would not have the upper method. Now, you do not need to memorize what all of these do. You've got the documentation. You can refer to it at any time. And I also want to mention that this is the complete list. This is not just a little bit of them. This is exactly all the stuff that you've got. And for each one, you can just refer to the documentation, or you can just play around a little bit and figure out what they do. For example, I can just call this one that says maybe is upper. So I could call it. So is upper. And if I run it, it's going to tell me false. So this object, the data that this object holds, which is string hello, is not an uppercase value, okay? All right, so we looked at methods and attributes, and we also looked at the type. And also when you just put in the label, so just obj, it's just going to give you the data, okay? So it's not going to return all the methods and the type and the memory address all at once. Python is just going to grab the data off of the object, and it's just going to display that to you in your terminal. Now let's also take a look at the memory address. You can get the memory address by just saying ID and then give the ID the object, and it's going to give you a number. So this is the address of your object. So if you have two objects in Python that have the exact same ID, it means that they are the exact same objects. Again, we're going to take a look at this later on, but for now, just know that you've got the ID function that you can pass an object to it, and it's going to tell you the address of that object. So we took a look at ID. We took a look at dir, and we also took a look at type. So far we've explored all these characteristics that each object in Python has. And again, remember, everything is an object. So you can do these things on anything that you've got in Python, be it a function, be it a list, be it a dictionary. You can just pass all of them to these functions and then read their characteristics. Now, right now, I also want to mention how you can create some of these objects. For example, we've got this object, but when exactly did we create it? Did we create it as soon as we said obj equals or something else? Now, in Python, specifically for strings, as soon as you say two double quotes or you say two maybe single quotes, you are creating a new object. So one of those green boxes is now being created with type string. So I can just say type of an empty string, and it's going to tell me string. I can get its memory address by doing this. Okay, so as soon as we say two single quotes or two double quotes, they're analogous, we are creating a new object. Now we can create a label as well and associate that with the object, or we can just create it as it is and leave it there and don't do anything with it. So let's take a look at that object that we just created. This object, which has this string hello, its type is str, which is string, and we also saw that it has some methods and attributes and also a memory address. Now, when we say hello in double quote, as soon as we do that, we are creating this object. And then when we say equal to something else, for example, obj, that is just our label. So we're creating this obj label and we're saying that this is going to point to this object. And we can have multiple of these labels. For example, we can create another one. We can say x equals maybe object. And now we've got two different labels that are going to point to the exact same object. Now let's take a look at this pretty quick. So right here, I've got obj. Let's get its ID like this. So this is the memory address. And I'm going to create another label. I'm going to say x equals maybe obj. Okay, they're also called variables. And now I've got both x and obj. But do you think they are two different objects, or do you think they are the exact same thing? Do you think that by this point we have created two different green rectangles in our memory, or did we just create one? Now the answer is we just created one. And there's a really easy way to confirm this. We can pass both of them to the ID function to get both of their memory addresses, and you can see that they are identical, meaning that we now only have one object in our memory. So we've got two different variables that are pointing to the exact same objects. All right, so now at this point, we've got some conceptual understanding about how objects are represented in Python. Again, remember that these objects are sitting in your memory, and the more objects that you create, you're going to occupy more memory. They're not magically sitting on your keyboard or on your monitor, they are in your memory. Now let me just demonstrate that very quickly. So right here, I'm going to try to create thousands and thousands of objects and then monitor and see how my memory usage goes up. So let's just create something called lists. I'm also going to comment this one. And right here, I'm going to put a for loop. So for I in range from maybe 0 up to maybe 2 million. So 2 and then 6 zeros. And right here, I'm going to create a new list. And here, I'm going to put 1, 2, 3, 4, and maybe 5. And then let's append the new list to the lists that we've got right here. So in each iteration, we are creating 6 new objects, and we are adding these new 6 objects to this main list right here. And we're doing it 2 million times. So right now we're creating 2 million times 6 objects, so 12 million objects in total. And just so that my application doesn't quit right away, I'm going to import this time thing, and I'm going to tell it to sleep for a few seconds. So time.sleep for 10 seconds. And now with this code, my application doesn't quit right away, and I can monitor and see what is my memory usage. So here in my terminal, I'm going to run the code, so python app.py, and if I go right now to my activity monitor, and here I search for Python. Now you've got this application if you're on Windows or Linux. On Windows, it's called Task Manager. So using this application, you can monitor all the processes that you have opened up on your operating system, and you can see how much of your resources each process is using. In other words, how much of your hardware is being allocated to each of the processes that you have opened up on your machine. And you can see the complete list of all of these processes. So you saw that my memory usage was around 200 megabytes by just these 12 million objects. Okay, so let's try to increase this number. So I'm going to change 2 million to maybe 8 million. So now we're creating 4 times more objects. I'm going to run the code again, go back to my activity monitor right here, and you can see that now my memory usage for Python, this application, is now 4 times the amount that it was before. So it's now 800. So the more that I increase this number, so let's now go with 20 million. So now we're creating 120 million objects in total. Now my memory usage should be around, well, 2 gigabytes. So let me run it and just monitor it pretty quickly. You can see that it is now around 2 gigabytes. So you get the idea. The more objects that we create, the more our memory usage. And all of these objects, all of these green things that we talked about are just in your memory. So you don't have unlimited power in terms of how much objects you're going to create. You gotta be careful not to create too much so that you won't end up with a very crazy memory usage. But that's not something that we're gonna worry about right now. For now, I just want you to understand that these objects are sitting in your memory. Alright, so now let's talk a bit more about lists. We talked about it, we saw 2 simple examples, but let's try to dig a bit deeper into lists and try to understand this data structure. So you probably know how lists work. You can just add in items to them. And again, remember, these items are just objects. We can maybe append something just like that we did right here. We can insert something. So I can say mylist.insert, and then we need to specify an index, maybe index 1, and then string Nicole. And I'm going to print my list again. And let's go ahead and run the code. And sure enough, you can see that now we've got this object right here as our first index. Alright, so now let's try to talk a little bit more about how lists are structured. Alright, so here's how a list object is structured. The type is list. If you have a list object, you give it to the type function. It's going to tell you list. And then you've got data, and then just like before, you've got methods, attributes, and also a memory address. Now, the data of a list is actually a collection of other objects. So in our example that we've got a few objects, we can see that we can have 23, 12, and then 5, and then string hello. So this object, this list object, is now containing 4 other objects. And each object of a list has a unique index. Indexes, as you probably know, start with 0, and then by each object, the index increments by 1. So that's the key thing to understand about lists, and that's pretty much it. That you can save objects inside of it. Now, what kind of objects you might be asking? Any kind of objects. So you don't have any limitations. It could be a function, because a function is also just an object. It could be any different object types, doesn't matter. It could be another list, it could be a set, tuple. You have no limitations whatsoever. As long as it's an object, you can save it in a list. And also each object has a unique index. And appending is pretty straightforward. When you're appending, you are adding a new object at the end of your list. So if we go ahead and say append maybe something, you're just going to add a new object, for example, string Jack, at the end of your list, and this is now going to be inside of your list object. So this is how appending looks like, and you can do it as many times as you want. Now inserting is the same thing, but now you have control over the index. So here you can see the index of each object. With insert, you can also specify an index, and that object is going to go to that index and then push the rest of the objects forward. So let's say that we have this list again, and we're going to insert at position 1 string Nicole. So index 1 is right here. We're going to create that new object with string Nicole, and we're first going to push all of these objects down. We will also modify their indexes because every single last one of them has now been pushed forward, and then we're going to insert that new object into the list. So pretty straightforward. Now, I also want to mention that in a lot of cases you will hear that lists are being called arrays, and that's actually true. Lists are actually arrays in Python. Python just calls them lists, but in reality they are just arrays because you've got objects, and each object also has an index. So that's it about lists. Again, super straightforward. Let's go into the REPL. Let's create a list. So 1, 2, and 3. And now if I get its type, you can see that it says that it's a list. We can also see all the items that we have available on a list. Insert is one of them. We talked about it. And also append, which is just like insert, but it's going to put at the end. Now we've got some other functions right here as well. For example, count and then index. A lot of them are really easy to understand. Just play around a little bit and then you'll see exactly what they do. For example, sort, again, pretty intuitive. You just call it and then it's going to sort your list. Index is another method. So I can say list.index, and as its parameter, it accepts an object, and it's going to find that object inside of my list object. So if I say object 3, it's going to tell me 2. So the object 3 in my list has index number 2. Index 0, 1, and 2. Alright, the next concept that we're going to talk about is tuples. We already saw lists, so here I still got my list in L, and we can just append stuff to it. We saw that we've got indexes for each item. Now, tuples are really similar. So let's see one example. I'm going to just create a new tuple, and for lists, we use brackets to create a new list. For tuples, we use parentheses to create a new tuple. And in this tuple, let's just put some stuff. So maybe Joe, and then 10, and then 24. Okay, so now I've got a tuple, and I can maybe get the index of 10 like this. It's going to tell me that the index is 1. So tuples, just like lists, have indexes for their objects. And I can get its type. So type of T, it says it's a tuple. And let's also take a look at dir and see all the methods and attributes that we've got available on it. And here, as you can see, it's pretty straightforward. Now, again, don't worry about the methods that start and end with 2 underscores. They are called dunder methods, and we're not going to talk about them in this video. That's a topic of another discussion later in the course. But you can see the other methods, we only got count and index. So it's pretty straightforward. Nothing is really going on right now in the tuple. And again, this is the complete list of all the methods and attributes, and you can access each one of them by just saying dot. Even the dunder methods. For example, here we've got this ln. So let's try that. So t underscore underscore ln and then underscore and underscore. If I run it, it's actually a method, so I have to invoke it. You can see that it's telling me the length of my tuple, which is 3. But this is not really how we want to interact with these methods. Instead, we've got this function called ln, and this is a better way of doing it to get the length of a tuple or a list. But just a quick point, this ln function is making use of this dunder method right here. But more on this later on. This is as far as I'm going to talk about these special methods. But apart from this one, you can see that a tuple is pretty straightforward. So what's the difference between a tuple and a list? Now, this brings us to a very important concept to understand in Python, and that is the concept of being mutable versus being immutable. So this is a very important thing that we need to understand in Python. Basically, if an object in Python is mutable, it means that you can change its data. And if an object is immutable in Python, it means that you cannot change its data, okay? Now, a list in Python is mutable. It's changeable. You can change your lists. You can create the list objects, and then you can change it. Tuples in Python are immutable. So once you create a tuple, you're stuck with it. You cannot change it unless you create a new tuple and then read the data from the previous object. But that object itself is not changeable. So that's the main important difference between a tuple and a list. Now let's try to play around with this a little bit. So here I still got my list, a list of 3 items. I'm going to get its ID. Again, this is the memory address of this object. So let's append something to this. So l.append, and I'm just going to append Joe. All right. So if I take a look at my list again, sure enough, you can see that it was changed. And if I get its memory address, you can see that it's still the exact same thing that I had before. So what does this tell us? This tells us that my list object was changed. And it's still the same object because we can see that the memory address was not changed. But my object's data was changed. So we say a list in Python is mutable, meaning you can change it once you create it. Now, how about tuples? So I got my tuple, and we said that tuples are immutable. You cannot change them. So we don't have a function called append or .insert or something like that. This t right here is going to be like this for good. So if I get its ID, this is it, and there's no way for me to change this tuple right here. So I can access the first item, and it tells me Joe, but in no way, shape, or form I can change this value. So if I do something like this, it's going to tell me that object does not support item assignments. Basically, what it means is that you cannot change your object because it is immutable. Now, as we keep going with the video, you're going to realize more and more why this is important and why we need to understand what objects are mutable and immutable. For now, just know that if an object is mutable, it means that you can change its data. If it is immutable, it means that you cannot change it. Now, what if I do something like this? So what if I've got this tuple, but now I don't want the last item? So I just don't want this 24, I just want Joe and 10. So how would we do that? Again, remember, we don't have a method that says .remove or something. We took a look at the complete list of its methods and attributes, and you saw that we only had to count and index. So we don't have something like that. So there's no way for us to remove the last item. But how about if we do something like this? So if I say Joe and then 10, and that's it. So I've got my t right here, and I'm now reassigning something else to it. So let's run it. Now, what do you think happened? Do you think my t variable is still the same thing as before, or do you think it's now a new thing? And how about the memory addresses? So I just want you to think about this for a second. Refer back to the concept that we said tuples are immutable, meaning that you cannot change them. So why didn't this return an error? So pause the video right now and think about this for a second, and also just guess what t is going to be. All right, let's give it a shot. I'm just going to run this t, and you can see that t is now this new tuple that does not contain 24. So what the heck? We just said that we cannot change tuples, but apparently we just did. So what just happened? Now let's try something. Let's try to get the ID of t. So this is my ID. Now let's try to set t back to the tuple that it was before. So Joe and 10 and 24. Okay, looks like I changed my tuple again. And let's now try to get its ID. And now clearly you can see that the IDs are different, meaning that now we've got two different memory addresses, meaning that we've got now two different objects. Now, this is a very important thing to understand. All right, so let's go into a diagram. So this is what we first had. T equals Joe 10, 24. Now, the way that you create tuples in Python, as we said, is using these parentheses. And just like in strings, that as soon as you put in two double quotes or two single quotes, you're creating a new string object. The same thing is true here with tuples. So as soon as you put in these parentheses, you're creating a new object. So this is the object that you're going to end up with as soon as you put down these two parentheses. Now, also as a convention, let's say that if an object has this red thing right here, this red X right here, we're just going to say that that object is immutable, meaning that we cannot change it. So we're going to stick with this convention throughout the rest of the video. All right, so here's the tuple object that we're going to end up with as soon as we say t equals that. Now remember, t itself is just a name. It's just a piece of string that's pointing to an object. So we've got our t right here, and this t is binded to this object. So every time you say t in your code, you're just referring to this actual object. They're just names. They're just strings that you call and you refer back to your original object, and nothing more. Now, the next thing that we did, we said t equals Joe and then 10. Now, what happens right now? Again, let's go back to the basic concepts. As soon as you put down these two parentheses, you are creating a new object. So as soon as you say this, you are creating this new object in your memory. And this is a new object, so it has its own address, a unique address that's different from this one. And it's also a tuple, and the data contains string Joe and this number 10. And also notice that we are assigning it. So we are saying to associate t now with this new object. So what Python does is that it already knows that t is pointing to this object, but now you're telling it to associate this t label with a new object. So Python is going to remove that previous object and kill that binding thing because you no longer use it, and that object is now gone. It's going to be put into garbage, so to speak, and then t is going to point to the new object. So that's what happens. Our object was not changed, well, it was removed. Obviously, you can do that. You can create and remove objects, but being immutable just means that you cannot change it. So I cannot go on ahead and now say to change this 10 to maybe 12. I'm stuck with this. If I want to do something like that, I should create a new object and then set its second item to be equal to 12. And that's it about tuples in Python. Again, pretty straightforward to understand. They're just like lists, but the difference is that they are immutable. So let's try something else. I've got my tuple right here, and I can save different stuff into my tuple. So let's create a new tuple, and inside of a tuple, we can just put in another tuple like this. Inside of that, I'm going to put in 1 and 2, and then as the second item, let's put some string, and let's run it. So we got our tuple, and inside of this tuple, we've got another tuple as its first item, and a string as its second item, okay? Now, what if we try to save a list inside? So let's try that too. We're just trying to figure out what kind of objects we can save to a tuple. We saw that with lists, we had no limitations. We could save any sort of objects. As long as they're objects, we can just save them. But how about tuples? So let's just try and play around with a few things. So inside of this list, I'm going to put in 1 and 2. I'm going to run it. And now I've got a tuple, and its third element is a list. So I can access the third element, which its index is 2, and it's going to give me a list. And if I get its type, so type of this one, it tells me that it's a list. So technically, we should be able to change this, right? Because lists, as we said, are mutable, meaning that we can change that. So let's try something. What if we do something like this? What if we try to access the list again and try to append something? So maybe append some string. What do you think is going to happen if I run it? So let's try it. Looks like it was good. Let's take a look back at our tuple, and you can see that now we've got this new list inside of our tuple. But what exactly happened? Did we create a new tuple object, or did we just change the tuple in one way or another? So let's take a look at the ID of t. So this is our ID, and let's run that thing again. So let's append now some string 2. Okay? And now let's get our ID again. Well, look at that. The ID did not change, meaning that we still have the same exact object, but clearly the object was somehow changed. So what the heck? Are we contradicting ourselves? We said that we cannot change tuples. We're not rebinding anything. It's still the exact same object, and we can confirm that by taking a look at the memory addresses. But apparently, the tuple is now changed. So let's take a look at a diagram and try to understand what's happening right now. So here we can imagine that we've got this tuple object, and it has some data, and the data, we saw that it's just a few objects. Each object has a unique address. So let's draw that. So this data, let's say that we've got 5 elements inside of this tuple. Now, the key thing to understand about tuples is that the objects that you're going to save in a tuple can either be immutable or mutable. So we can save strings, numbers, and also lists and dictionaries and anything else. And because this object right here is mutable, we can go ahead and change this object specifically. Now, when we are doing that, we are not actually changing our original tuple object. Sure, the object that it's going to hold is now different, but the original tuple is still the same thing. The index of that item is still 3, and that item is still right here. We did not remove it. We did not change the object itself, meaning that the memory address of the object is still the same thing, but now the data of this object was changed. And this is a valid thing. You can do this in Python. So that's something that might throw people off a little bit, that we say that tuples are immutable, meaning that you cannot change it, but we saw one example that you could do something like that. But it's pretty straightforward to understand. All you need to know is that a tuple can contain any valid Python object, and those objects can either be mutable or immutable. There's no restriction on that. because the data right here is actually just some addresses that are pointing to these different objects. Okay, so addresses and indexes. These objects are not really part of the tuple itself, rather the data is just pointing to them. So for as long as you don't change the memory addresses and you do not change the indexes, you're good to go. Anyway, so that's it about tuples. Now we should fully understand tuples. You can do some operations on tuples. For example, here's my tuple. I can maybe add something to this tuple, add another tuple to this tuple, and here I'm going to say maybe str and something random. And now you can see that I've got this new tuple, so I added these two tuples together. So here I've got this tuple, it has its own address. Here I'm creating a new tuple, and then I am creating another tuple that's going to read the values of this tuple and this one, add them together, and now we've got this new tuple. So still I'm not changing my original tuple. My original tuple is now gone. It's now put into garbage, but I've got a new tuple. So if you get its memory address and then this one's memory address, you're going to see that they are different. And again, remember, the more objects that you create, the slower your application is going to be. So if you have a case where you're going to have a lot of items and you're constantly adding them together, it makes sense to not go with tuples and go with lists, because lists are mutable. You can just add new stuff into them without needing to create a new object. But if you go with tuples, you're constantly creating many more objects and then putting the previous ones to trash. So that's a heavy process, and it makes much more sense to go with lists in a case like that. But we're going to talk more about why being immutable is important and why should we care. Now, you might be asking, what are the objects in Python that are mutable and the objects that are immutable? Here you can see the list. So in terms of mutability, lists and dictionaries and sets are mutable, meaning that you can change them. And tuples, strings, and integers and floats are immutable. So once you create them, that's it. If you want to have a new thing based off of that, maybe add a new thing to that previous one, you have to create a new object. And these are the common data structures that you're going to work with in Python, especially when you're starting out. And it's important that you get really comfortable with all these types that you can see right now on the screen. We've got some other object types in Python, but we're not going to talk about them right now. And for now, just focus on these few ones. Once you get really comfortable with them, it's going to be really easy moving on to other data structures. But these are the most common ones, and you're going to be dealing with them a lot in your Python codes. So look at this. Strings are immutable. Now, what complications does it bring? So let's go back to the REPL and try to play around with this a little bit. So I'm going to define a new string. I'm going to say hi there. And I've got my string. Let's get its ID. And this is its ID. So what if I want to change this string to uppercase? So remember, strings are immutable, meaning that we cannot change them. Once we create the object, we are stuck with that. If we want to modify it in one shape or another, we have to create a new object, and then based off the data of that previous object, we're going to fill that new object. So let's first take a look at the stuff that we have available as the methods and attributes. Let's see if we have something called upper. We should. I'm just going to search for upper. And there we go. So we can use that function, so str. And again, remember, you can access all of these items by just saying dot and then specifying that item. If that item is an attribute, you're just going to run it and that's it. But if it's a method, you have to invoke it like this by using these parentheses. So let's run it. And you can see that it gave me this new string. Let's take a look at our previous string. And you can see that it's still the exact same thing. So my string was not changed. If I get its ID, it's the exact same thing that I had right here. So what if we want to make it an uppercase? What sort of options we have available? Well, you can always rebind. So you've got all these name variables. You can always tell them to point to new objects. You've got no limitations whatsoever in terms of that. You've got these variables. You can make them to point to anything that you want, as long as they're just objects, and you've got full control over that. The only thing is that each variable can only point to one object at a time. So right now, this str name is pointing to this hi there that is lowercase. And I can easily change that. So I can say str equals this new thing. So I can just say str.upper again, because this upper is going to return a new object. So it's going to create a new string object. And now I'm just saying that take this name thing, take this label, and now point it to this new string that this method is going to return. So let's run it. If I get my str, you can see that it's now uppercase. And if I get its ID, you can see that it's now changed. So the ID of the original string object, you can see that it ends with 24, and actually this object is now gone. It's now removed from my memory, so Python saw that I did this rebinding right here. Python is smart enough. It's going to see that the previous object is now no longer used, so it's just going to remove that from the memory, and then it's just going to rebind this str to this new object right here. But you can see that they are two completely different objects with two different memory addresses. And that's the same thing with numbers as well. So if I create a number, if I set it to 200, if I get its ID, this is my ID. And if I want to just add 1 to that number, so if I say num++, and oops, look at that. It tells me that we don't have access to something called num++. If you're coming from other programming languages, you have most probably used this num++ that you can just use to increment your numbers by 1. But in Python, you do not have access to something like that. Now, why is that the case? Again, let's go back to the concepts. Numbers in Python, including integers and floating point numbers, right now this number is an integer type, they are immutable, so we cannot change them. If we want to do that, we have to say num equals num plus 1. And now my number is changed. Now I have 201. So think about it. What we're doing right now is that we are reassigning. So we are creating a new number object, and then we are rebinding our variable to point to the new thing. And we can verify this very easily. So let's get its address right now. The address is this. Let's now add 1 to number. So num plus equals 1. And now my number is 202. And I'm going to get its ID again. And now you can see that they are totally different. Now you might be asking, hey, this is not super efficient because we are creating a new complete object and then removing the previous one from our memory. So if we want to keep adding a number, this is a heavy process compared to other languages that you can just modify that thing itself without needing to create new objects, creating new memory addresses. Well, you're right. Python is not the fastest language to develop applications with, and that's just one of the characteristics of Python, although it's super simple. So you won't be using Python if performance is really important to you and you want to create the fastest possible applications, but that's actually not always a concern. You could be just fine with having a little bit slower application, but having a much less development time. Because it's really easy to develop applications in Python. You don't have to care about a lot of things. It's super simple and it's also super clean. You can see that we've got all these objects and we don't have a lot of exceptions. They work really neatly together, and we're going to keep seeing this more and more throughout the course. So let's go back to this list again. Remember, tuples, strings, integers, and floats. These are the most well-known types that are immutable, and sets, dictionaries, and lists are mutable. And that's it about tuples and being mutable or being immutable. All right, so now let's talk about some of the ways that you've got to create new objects in Python. So far we talked about two of them. One is just two quotes, you can put stuff right here, and now you are creating new string objects. Another one is to just use this one, and now you are creating new tuples. So if I get the type of that, it's going to tell me a tuple. I can also get the ID of this, so it's memory address, and it's going to tell me something. It's not going to tell me that nothing exists, because as soon as you do this, you are creating a new object in Python. Same if I just do two brackets. Now I am creating a new list object in Python, and you can see that I can get the memory addresses. So what are some of the ways that we've got to create objects in Python, and do we also have an alternative? Let's talk about that. So generally, you've got two different ways in Python to create objects. One is using the literal syntax, and the other one is using a constructor. So let's take a look at a few of them. Now, for Boolean values, you can either say false, true, or use the bool constructor. So let's take a look at this very quickly. So if I just say false, I am creating a new object. If I get its ID, you can see that it has a unique ID. Same thing with true. So when we say true and when we say false, we are creating a new Boolean object. Another way of doing that is to use the bool constructor. So we can just use bool, and it's going to give us a new object. And if I get the ID of this bool, this is what it's going to return. By default, it's false. But if you give something to the constructor, for example, this one, it tries its best to convert that into a value that corresponds to a Boolean value. So right now, it's going to return true. Now notice that I ran it 2 times and both are true, so because they are the exact same object, Python is not really quite creating a new object, it's trying to be efficient, so it's just simply pointing to that previous object that it got. So rather than just removing that previous object and then pointing to the new one, because they are exactly identical, it's just going to keep pointing to the exact same thing as before. So it tries its best to be efficient, but it's not always the case. Now next up, we've got string. In string, you can either use 2 double quotes or 2 single quotes to create a new string, or you can use the string constructor. Let's also take a look at this. So I can create a new string like this. If I run it again, you can see that it's still the same thing. So again, it's trying to be efficient. Alright, so I just ran this ID thing a few times, and you can see that it keeps giving me back the same ID, even if right here that I changed my string. Now, don't be fooled right now and say that it means that strings are mutable. Well, what's happening right now is, again, Python is keep pointing to the same location, and it's actually just using the same exact address that it had before. But if I keep on running it, you can see that it's not always consistent. For example, right here, it gave me a new address, but then right here, it's still the same thing, but it now gave me something else, okay? So this could happen in Python. Python could just create an object that still has the exact same address as before, but well, actually, you are creating a new string object. It still is at the same exact location, but it's a new thing. So str is another constructor that's going to give you new objects. All right, let's now quickly take a look at all the other ones. So for floating point numbers, you can either just use the literal syntax or use the float constructor. So literal syntax just means using the thing as it is. You're still creating a new object, but you're not using a constructor, you're not using a function, you are just putting it down. Python is going to see that, and then it automatically knows that you intend to create a new object, so it's going to do that for you. For integers, you can just put a number, or you can use the int constructor. Now for lists, we saw this previously, you can either use these brackets, and you can also use the constructor. You can just say list, and this is now going to create a new object for you. Now for tuples, same thing, you've got parentheses, and you've also got the constructor. For dictionaries, we're going to talk about dictionaries later on, but you can both use the literal syntax to curly brackets, or just use the constructor like this. Now, when you use the constructors in Python and you pass them something, you pass them an object, the constructor is going to try its best to create an object of that new type off of the object that it had before. So it's going to take the data of the previous object and try to use that to create a new object for you off of that data. So if I just create a list of 1, 2, and 3, so I've got a list right here, its type is a list, and if I pass this to a tuple, if I say t equals the tuple constructor, and I just give it the list object, now this t is pointing to this tuple object, and you can see that its data is coming from that previous list. So Python took this data, and it tried its best to create a new tuple based on that data, so it came up with this thing. And type of t is a tuple. So this sometimes works, sometimes it doesn't work. So if I try to give this tuple maybe the false Boolean value, it's going to give me an error and says that object is not iterable, okay? So if an object is iterable, you can pass it to the tuple constructor, and it's going to create a new tuple off of that data. Now we're going to talk more about what it means to be iterable, but for now, just know that some objects work with some constructors and some don't. And this is how we can convert your data back and forth between different types. Same with the string constructor. So if I just run it and give it a number, it's going to convert that into a new string. So it's going to take this number object, it's going to take its data, and then it's going to create a new string object and just put this thing right there. So it's going to try its best to do this conversion. Now let's talk about one more, and that is the set. This is the next topic that we're going to talk about. Here you can either use the set constructor or you can use the curly brackets, but now you should also put in some values as well because it's the same thing as a dictionary, and to not confuse them together, you also need to pass in some initial values so that Python will know that you are going to create a set and not a dictionary. Okay, so there you go. This is how we can create objects. You've got 2 ways of doing it, either using the literal syntax or using the constructors. They will do the exact same thing, and you got both of the options. With constructors, you can also create objects off of another object of another type, which can be pretty useful from time to time. I would like to take a quick break and say that this video was not sponsored by anyone. That's why I would like to promote our Node.js backend course on Udemy. You can check it out by opening a new tab in your browser and going to this link, codadev.ca/UNCC. It will redirect you to the Udemy course page and apply a coupon. If you buy the course using this link, Udemy takes only 3% of the total amount. Otherwise, it takes about 60%, sometimes even 90% of the total amount that you'll pay. So it'll make a huge difference if you use this link to make a purchase. It will be a great support for this channel and the course and future content and projects. And that's the best way of supporting. The method of teaching is similar to that in this video. The course is focused on the core fundamentals of backend engineering, and we will not be installing a whole bunch of packages. This course will make you a much better software and backend engineer, provided of course that it's the right fit for you, which you can figure out whether or not that's the case by checking out the description and free preview videos. If you're looking into getting into backend development or you are already doing it, I'd highly recommend this course, and a lot of the concepts apply if you want to use Python in backend development as well. It's always good to have different perspectives on a single concept. Alright, thank you very much, and now back to the main video. Alright, let's now talk about the next important data structure that we need to understand in Python, and that is sets. The way that you create sets in Python, as we said before, is using two curly brackets with a value inside of it. If we don't do that, if I get the type of this, so now I'm creating this object, it tells me that it's a dictionary. But if I put some value here, it's going to tell me that it's a set, okay? So that's how you create sets in Python. So let's create something with some values. So s equals maybe 1, 2, and 3. So now I have this set right here with these values inside. Now, a set in Python is a collection of values. And the difference between sets and lists and tuples is that you do not have indexes here. So I cannot say to give me index 1 right here. It tells me that indexes on sets is not supported. So that's the main difference between sets and lists and tuples. Another difference is that you cannot have duplicates right here. So if I add this for object to my set, now sets are also mutable, so you can change them, you can add in new elements, you can remove other elements. Now here's my set, so now I added this for object. But if I run it this many times, what do you think is going to happen? So let's take a look at our set, and you can see that it's still the exact same thing because duplicates don't matter. Now the reason why this is the case is because sets in Python are just representing sets in math. So if you understand sets in math, this should be something fairly easy for you to understand. So let's take a look at that pretty quick. Sets in math, you've probably taken some discrete math in high school or college, and you know what sets are. So we say set A equals this one with these elements. We also use this curly bracket syntax in math. And we also have the Venn diagram right here. So we say that this is how we represent our set. Okay, so you probably remember this. If you don't, there you go. So this is what a set is in math. So let's say that we've got another set. So set B, 233 and 102. And we can represent this using this diagram. And maybe we'll try to get the union or intersection. And this is how it works. Okay, so this is the Venn diagram. And this is the set notation. Now again, two important things to understand about sets. One, duplicates don't matter, and second, order does not matter either. So if we say that we've got set C of 2, 1, 4, and 3, these are the exact same elements that we have here in set A. So we say that set A and B are equal. So there you go, sets in math. And Python also is built on the same thing. Python is trying to represent sets in math, so it adheres to the same rules. Duplicates don't matter, and we don't have order, okay? So if I get the dir of my set, if I take a look at it, you can see that we've got all these things that we've got in sets in math, such as union and intersection, and you could do all of that here as well. And you can remove elements, you can add new elements, and again, remember, sets are mutable. Now, because order does not matter in sets, here you can see that I added this 4. It appeared at the end, but it could not be the case. So you can go on ahead and play around with it. You can add in as many items as you want to it, and some of them you'll see that will end up at locations not exactly at the end. Okay, so order does not matter, don't be confused, and a set is just a collection of items. So let's try to play around a little bit. Let's try to add maybe a tuple. Let's see what's going to happen. So I'm going to add a tuple of 1 and 2 to my set. And it looks like it worked. So now I've got my tuple, and well, here's what I was just talking about. The tuple did not appear at the end, it appeared right here in the middle. It might sound weird, but that's just because we don't have order, so it could randomly appear at any point. Let's try to add something else to this set. So here, let's try to add maybe a set inside of the set. And it tells me that unhashable type sets. So that's something that we got to talk about right now. Now, what if we try to add a list? So we already added a tuple inside, but what if we try it with a list now? So 1 and 2. Let's see what's going to happen. And, well, it gives me the exact same error that it tells me unhashable type lists. Now, this is another important concept that we need to understand in Python, what it means if an object is hashable or unhashable. And if we understand this, we're going to have a better foundation to understand and work with dictionaries. Now, in hashing, what happens is that we're going to get a value, and then we're going to do some sort of mathematical operations on it, and then we're going to end up with a result. The important part right now is that the result should always be the same if our input is the same. And we got a function for that in Python, and that's simply called hash. So here I can give it a value, maybe an integer object, and it's going to hash that for me. Now in this case, it ended up being the same thing, but if I maybe give it a string like this, you can see that this now gives me this number. I can also try to hash tuples, so this one, and this is the number that it's going to end up with. And if I give it the same tuple, you can see that it's always going to be the exact same thing. But if I just change one thing right here, so if I change 2 to 1, you can see that now I end up with a drastically different result. But then again, the important thing is that it will always be the same thing, this gigantic number for hashing this one. Now, we can't hash things like sets and lists, and we're going to talk about that in just a second, but that's the idea of hashing. Now, we can also do the same thing ourselves. In fact, I've gone ahead and wrote a piece of code for it. So here I'm going to create a new file. You don't have to do this, just watch me do it. So I'm going to call this customhash.py, and I'm just going to paste this code that I wrote before I record this video. So here I've got this custom hash function. I give it a value, and then it gives me a number, okay? So if I call it with this value, my value, I've got this tuple of some random values, but we don't care. And I'm calling this custom hash, so I'm hashing this value right here multiple times. So let's go ahead and run it. Here in my terminal, I'm just going to say Python custom. And if I run it, you can see that I always get the same value. So that's the idea of hashing. Now let's just take a look and see how I'm doing this. I'm hashing different items. For example, for hashing an integer, I'm just grabbing the number and I'm multiplying it by a gigantic number, and then I'm getting its remainder by this number. And that's actually how hashing is done. We just multiply and then we get the remainder by some number like this. Maybe 10,000, a million, something like that. So pretty straightforward. And if I give it the same integer value each time, maybe integer 32, you can see that 32 multiplied by this value and then its remainder by this is always going to be the same thing. But if I change it by just one value, it's going to be something quite different. Now, same thing for hashing strings. For strings, I'm grabbing the string, I'm looping through the string and getting each character. Now, each character in your computer has a number associated with it. And that's the same thing in all computers, in all languages. So I'm getting that value and I'm multiplying by some random big number, and then I'm getting its remainder. Okay, and if it's a tuple, I'm doing the same thing with all the elements in the tuple, and then I'm adding all the numbers and then getting its remainder by this gigantic number. So I can now hash tuples, I can hash strings and integers. Don't really worry about the syntax right here. That's all that I want you to understand right now. So I'm hashing this tuple, and let's just say that I'm going to change this f. So let me just run it one more time. So you can see that I always get this value. And if I just change this f to capital F, if I save and run it again, you can see that now my result is totally different. Okay? So that's what hashing is. And in Python, we've got this hash function. And what Python does for each element in the set is that it's going to hash that element and then save the hashed value. So it's going to save the hashed value, which is pointing to the actual objects. Now, I want you to think about it for a second. Based on what we talked about, what kind of objects make sense to actually hash? So we saw that we can hash strings, we can hash numbers like this, we can hash tuples, but we couldn't hash lists and also sets. So why is that the case? Now, if you think about it, here in my custom hashing, what I'm doing is that, again, the main point is if our input remains the same, we want our hashed value to be the same as well. Okay, that's really important. We cannot mess that up. So one key requirement for this in Python is that our value should be immutable. So if you get a value, if you get an object, okay, so this hashing is just hashing objects, and you hash the object, you end up with a value. But if you change the object and give the changed object to the hash again, now you're going to have a problem. You will not end up with the same result because your object was changed. Okay, so that's the requirement in Python for hashing. If you want to be able to hash something, that object has to be immutable. So tuples are immutable in Python, so we can easily hash them. Strings are also immutable in Python, so we can also hash them. But sets and lists are mutable, so we cannot hash them. Now, why do we care? Why do we care about this hashing so much? Let me just show you one diagram to get some idea about why this is such an important concept. Now, in short, it all comes down to speed. We want to speed up the performance of our application, and hashing helps with that a lot. Let's see why. So your memory in your computer is represented like this. So you've got different boxes. Each box holds 8 bits, 8 zeros and ones, and each one also has an address, okay? And the address is actually also zeros and ones, but I'm now showing that in decimal, but we can easily convert them back and forth. But the main thing that I want you to understand right now is that your memory is like this. So we can have another box, it's going to have another address, and we can have millions and millions of these boxes into our memory. Okay, so let's say that we've got all these boxes, maybe that's a data structure that we've got in Python, and we also got this box right here, its address is this. So in this data structure, be it a list or a set or a tuple, we want to access this box. So you can imagine that in this box, we're saving some integer or we're saving a Boolean value, it doesn't matter. Now also your memory has a pointer that's pointing to a current location. Okay, so you can move this pointer around and that's how you access your memory. So that's how your CPU works. It has this pointer that's pointing to a location in your memory. It grabs the data from these boxes and then it executes or anything like that. Okay, so if you change a value, this pointer has to go to that location that holds that value and then your CPU is going to change that. Okay, so pretty straightforward. So let's say that in this data structure, you want to access this element. You want to read its value and then just print it. And your pointer right now is pointing to this location in your memory. Now you've got two options of doing it. You can just check each box like this. So you check this one, and then you check the next one. And by each one, you check them with the value that you've got. So you're trying to find a value in your data structure. And the value that you're looking for is 4 zeros and then 0 and then triple ones. Okay, so you're going forward one box at a time and you're checking all of them to see which one has that value. And you can imagine that this could cost you a lot because you're checking against each object. Now another option that you've got is that you've got the number right here and you know the address of the point that you gotta get into. So you just add that in and you can quickly move over to that location. So computers are really efficient with dealing with numbers because memory addresses are just numbers and you can easily move this pointer around if you know the address. So you can just subtract some numbers, add some numbers, and this pointer is going to go exactly to that location. So now if you're looking up a value, you don't have to check every single element. You just move quickly to that point and it's instant time. You're just doing one operation. If you've got a data structure with 1 million items, you're not doing 1 million operations, you're just doing one. Now, hashing helps with this. When you're hashing in sets or in dictionaries, which we're going to get into later, you are saving these hashed values and they kind of correspond to your memory address, but we're not really going to talk about that. You'll learn a lot more about this when you get into learn about algorithms and data structures. For now, I just want you to have this idea that when you're hashing in a set, you are saving these hashed values, and then when you look up an item, Python is going to hash that value that you're looking up, and then it's going to check it against these hashed values. So now it's basically just adding numbers together, and it's instant time, and this is really fast. So here in my Python, I've got this set. If I say 2ns, it tells me that it's true, okay? So what happened right now is that Python took this value, it hashed it, and then it checked it against this set. But in this set, we've got all these hashed values. So it quickly moved to that memory location. You could imagine what just happened. We saw it in the slides. and it's quickly going to tell me that it's true. Now, if I have a list, let's say that we've got L, and it's the same thing. So now we've got this list, and we've got this set, and this list has the same data. So now if I try to look up an item here, so if I say 2 in L, now it still tells me that it's true, but what happened right here in this list is that Python checked this 2 against each element. So the first case that we saw in the slides, that pointer was moving one box at a time to figure out whether or not this element exists in the list. But whereas in this case, checking in the set, Python just hashed the value and it quickly moved to that box and it gave us this value. So that's the idea of hashing. It's also used in dictionaries. You can imagine that if you've got a million different records and you're saving them all in your Python code, maybe as a dictionary or as a list, and you're creating a web server, and for each request that you get, you're going to find an item in that thing. If you use a dictionary, because dictionary is going to hash, it's going to be instant time. So you're not going to check a million objects each time you get a request. You're just going to quickly go to that point, grab the value, and that's it. But if you use a list instead, it's going to take you a million operations by average, because you're checking against each element until you find it, to find that value. And that could be a heavy operation. You could be having maybe a billion objects, and checking against that many objects, billions of objects, is probably going to take maybe half a second to complete if you use a list. But if you use a dictionary, it's just microseconds. So that's the idea of hashing. And remember, sets, they hash all the values before saving. So if something cannot be hashed, if an object cannot be hashed in Python, then it cannot be saved into a set. So that's the first point. The second point, in order for an object to be hashable, it has to be immutable, okay? So lists are immutable. We can change them. So if I hash this thing, and then if I go ahead and then change this object and I try to hash it again, well, I'll end up with a different value, but that's something that we're trying to avoid in hashing. So in Python, it does not allow you to hash mutable objects. All right, so that's the idea of sets in Python. And now that you understand this, that you understand what hashing means, now we're going to have a better time understanding dictionaries. So that's the next topic that we're going to talk about. Okay, dictionaries. Dictionary is one of the most powerful data structures in Python. You're going to end up using it a lot. It's really flexible, really fast, and really powerful. So we already know how to create a dictionary. You just have to say 2 curly brackets, and that's it. You've got a dictionary. Now, the main difference between the dictionary and other data structures that we talked about so far, lists, tuples, and sets, is that in a dictionary you've got key value pairs. So it's still a collection of objects, just like all the other 3 data structures that we talked about so far. But again, the difference is that each object will now have a key. And this now makes dictionaries really powerful. So let's just see one example. So the key is also an object, for example, name Joe, and then the value corresponding to that key is also an object. And then I can have foo, maybe a number, okay? And actually I need to wrap foo in these quotes because it's not a valid object as it is. And there we go. And let's also save it to a variable. So d equals this. And now we've got this dictionary right here. So nothing too crazy is going on. It's just a collection of values. And let's see how it is represented in Python. So let's go to a diagram. Let's say that this is our dictionary object. So we've got this object, its type is dict, meaning dictionary. We've got some data, and it also has all of its own methods and attributes as we saw before. So the way that its data is represented is like this. So the data is a collection of key and values. Now here I've put this X for the keys, meaning that our keys should be immutable, okay? We cannot put a mutable value for a key in the dictionary. And the reason that keys should be immutable in a dictionary is because a dictionary will hash the keys before saving them, just like a set. And we talked about it. It does that because it wants to be as fast as possible. So now if we have a dictionary of a million objects, it's going to be instant time to look up a value. It's not going to take us a million operations to find that. It's just going to take us one simple operation. We're just going to hash our value that we want to look up, and we also know the hash value of the first element in the dictionary. So we just add that, and then we quickly jump to that memory location, to that point where the element that we're looking for is located. So keys in a dictionary have to be immutable. And again, keys and values are just objects. So let's say that we've got this key right here, name, it's a string. Again, remember, strings are immutable, so we can use them as a key of our dictionary with no problem. And let's say that the value is string Joe, and in this case, our value is also immutable, but it doesn't have to be. So this is one item in our dictionary, okay? We've got the key and we've got the value. Let's say that we've got this other one, foo string, and then its value is this 88, which is an integer. Again, they're both immutable. And here's another one, city, Toronto, and here's another one, items, and this one is a list. So again, as far as the keys are immutable, we're okay, but values could be any valid object in Python, such as lists, sets, another dictionary, a function, really anything. The only limitation is that the key has to be immutable, and that's pretty much it. So again, remember, a dictionary is a collection of items, as you can see right now on the screen. And you can easily loop through, you can easily add in new items, and also remember that you cannot have a key that does not have a value, and also you cannot have a value that does not have a key. Both of them should be present at the same time. Alright, so let's go back to the terminal. So here's our dictionary. You know how it is now represented. We've got the keys. You have access to this method on each dictionary, and if you run it, it's going to give you the list of all the keys that you have in that dictionary. So here's one method that you need to know. Another one is values. And it does the same thing, but now instead of giving you the keys, it's going to give you the values. So you can now iterate over it. And you can see that it looks like a list, but actually it's not quite a list. So if I get its type, so type of d.values, you can see that its type is dict values. But it's still really similar to lists, and you can easily iterate over them just using a regular for loop. Same with the keys. Now we've got another important method available on it, and that's called items. And when you call it, it's going to still give you a list of those items, but it's going to give you each of the key value pairs in a tuple. Now if you try to access the first item right now, you can see that it gives me an error, that it says that it does not support indexing. Same if I try it with keys. So even though it looks like an actual list, it's not really quite a list, and you can see that we don't have indexes. But again, you can think of it like something that you can easily iterate over, and it functions similarly to lists, but that's really as far as you need to know about them. Now, if you want to get a specific value in your dictionary, maybe let's try to get name, you can either use this syntax, which I'm sure you've probably used at this point, or you can also use .get, give it the key. So you have to give an object to this .get. That object, if it exists as a key in the dictionary, it's going to return the value of that to you. And if it does not exist, so something like this, it's not going to give me an error. It's just going to ignore it. But if I use the other syntax like this one, actually I need to remove that dot. There we go. Now this one is going to give us an error that says key is not found. So sometimes you have to look up an item in a dictionary, but that item might not exist. You do not know if you have it or not. So in that case, you should use .get and not this one, because this one is going to return an error. And the other one, you can just throw it in an if statement and it would work. Now, if you want to delete an item in Python, now deleting objects is actually pretty straightforward in Python. We haven't talked about it to this point, but you can just use the del thing. And if you pass in an object to it, it's going to delete it. So I can say del d, and now d does not exist. So del is a keyword in Python that you can use to delete objects that you have created. So we talked about it. You've got all these different ways of creating objects, either literal syntax or constructors. And now if you want to delete them, you can just use the del keyword. So let's just define our dictionary again and say that we want to delete this foo thing. We can say del and then specify my dictionary, get that value, foo. And now that collection of key value pair is completely gone. Again, notice that we cannot just go ahead and say delete the maybe value or just a key. It does not work. They are a pair, so we need both of them at the same time. So if we try to delete the key or the value, both of them will be gone from our dictionary. Now this del also works with lists. So if I have this list right here, of 1 and 2 and 3, I can say del, let's try to delete the second item. So del 1, index 1, and now we no longer have that item. So del just removes these green boxes in our memory that we talked about. It just goes ahead and wipes those green boxes off of our memory. So we no longer have that particular object in our memory. It's now completely gone. All right, so let me go into my code editor. And right here, I'm going to create a new file. I'm going to call it dict.py. And right here, let's create a dictionary. So my d equals name Joe. And then foo, some sort of a number, maybe this one, and then maybe my underscore items. And here, maybe we're going to have some sort of a list like this. And also, do you think we can put a tuple right here? So if I try to put 1 and 2 and say this is some string, and now if I try to print my d and grab this one, what do you think is going to happen? So I'm saying give me the key value pair, actually just the value in this case, that has the key of a tuple that contains 1 and 2. Do you think we're going to get an error, or do you think it's just going to work with no problem? Let's go ahead and run it. I'm going to head over to my terminal. I'm going to say python dict.py, and you can see that I got some string. So it works just fine, and again, go back to the concepts that we talked about. Keys in a dictionary can be any object as far as they are immutable, okay? And also hashable. So we have to add that thing in because a tuple is immutable. And if you add a list to it, like this, so a list that contains 2, now this is not going to work because now we have immutable objects in our key. Sure, the tuple is still immutable, but because of this mutable thing that we have inside, it's going to give us some problem. So if I go ahead and try to run this, you can see that it gives me this error that unhashable type lists, okay? So what Python does is that it's going to pass all of these key objects to the hash function. And also when you are looking up values, maybe using this syntax or using .get, it will also hash that item before it looks it up. And if you have something that is not hashable, you're going to have an error. So that's basically the only limitation that you have in Python keys. They should be hashable. Now that also means that they should be immutable. But if you have an object that is immutable but contains something that's mutable, that will not work. And you should by now know exactly why that is not the case. All right, so let's now try to loop through the dictionary and just print everything that we've got. So I'm just going to remove this and change it back to just a tuple. And let's try to loop over. So I'm going to say for I in my d, and let's just print I and see what we've got. So I'm going to comment this line, the print line, and let's go ahead and run it. I'm also going to put this right here and put this right here, so that now we can easily run and see the result that we're going to get. All right, so you can see that it ran. I see name, foo, my items, and my tuple. This would actually be the same if I were to say instead my d.keys. So that's basically the same thing. You can see that I get the exact same result. So if you pass in the object as it is, it's just going to loop through the keys. Now, up until this point, all of these data structures that we talked about, lists, sets, tuples, and now dictionaries, they are all iterable. And that's something that we also need to understand, what it means if an object is iterable. So each object in Python, each one of these green boxes, could either be iterable or non-iterable. And if that object is iterable, you can just pass it to the for thing. So you can just say for something in that object, okay? And then the for loop is going to iterate over it. But again, the key point is that that object has to be iterable. Now, there's a very easy way of knowing whether or not an object is iterable. If an object is iterable, you can pass it to the iter function. So we've got this iter function, and if I pass in a list to it, a list of 1 and 2, you can see that it gives me this thing, list iter objects. So it didn't give me an error, which means that a list in Python is iterable. We can create an iterator off of it. If I try it with a tuple, you can see that it also works. How about sets? Now if I try it right here, you can see that sets also work. So right here, In the for loop, we can put either a tuple or a set or a list and anything else that we can pass to the iter function. Do we still have the dictionary? Yes, we do. So let's try to pass the d.keys to the iter. Let's see if it works. And you can see that it worked. So d.keys, even though it's not a list, it looks like a list, but it's not actually a list, it is still iterable. So we can still iterate over it. We can give it to the for keyword, the for loop, and it's going to iterate over it. Now, how about numbers? Can we put a number right here? Do you think it's going to work? Now, it might make sense. You might think that I is going to be maybe from 0 up until 34, but it's not actually the case. So if I pass a number to the iter, it's going to give me an error that says object is not iterable. So we cannot do that. Although you can do it with range. So if you give that 34 object to the range function, now the range function is going to return an object that is iterable. And this is now going to work. Okay. So if I pass that, so range of anything, it's going to work. Now, when you pass an object to this iter function, if the iter function is successful, it's going to return something that is called an iterator. So I've got I equals iter. Let's pass in a list to it. 1 and string and maybe this number. All right, let's get the type of I, and you can see that it says it's an iterator. Okay. Now, an iterator is really easy to understand. You just give this iterator to the next function, and it's going to give you the first element of that list, and then when you call it again, it's going to give you the next one. So if I run it right now, it's going to give me 1. If I run it again, it's going to give me string, and then this one. And now if I run it one more time, it's going to give me an error that says I am now at the end of the iteration. So nothing too crazy, really. It's just an iterator, and you can just give it to the next function, and it's going to give you one item at a time off of that thing. And that's what actually happens in a for loop. When you pass something to the for loop, it's going to create an iterator off of it using the iter function, and then it's just going to call this next behind the scenes for you. All right, so that's pretty much all that you need to know about iterators for now. And let's also take a look at the dir of a dictionary, so that D that we've got. So a few items that we've got right here. One is get that we looked at, values we also looked at, items, and also pop, so you can remove items, remove the pairs from your dictionaries, also using this pop. And let's try it. So if I say d.pop and then key name, now my dictionary is now empty because I removed that object. And again, don't worry about the dunder methods for now. We're going to get into them later in the course, but that's pretty much all that you've got. All right, so let's now go back to our for loop and try to improve this a little bit. So let's try to end up with something that's going to loop through the dictionary and says this dictionary has key this and value that. Let's see how we can do it. Now we've got a few ways of doing it. Again, go back to the basic concepts, try to play around, and you should come up with something. So one way is to loop through the keys. So my d.keys. And now in this case, we're going to get each key, and here we can print my d has. And let me try to use format strings. So I'm going to put an F right here. And here I'm going to put one value. So my d has key. And its value is, now we can either say my d dot get key or just my d in brackets and then key. So let's run this. And sure enough, you can see that we've got what we were expecting. So my d has key name and its value is Joe, has key foo, and this is its value, and then my items, and then this is the value. Now we've got another way of achieving the exact same thing. Instead, we can say dot items. Now again, remember, it's going to return a list-like thing that contains each item in a tuple. Let's just go for EL, short for elements. And then here I can get the first index. And right here I can get the next index, so index 1. And now let's run it again, and we get the exact same thing. So again, this is going to be a tuple, so if I just say print type of EL, if you're not sure of what is this thing, just know that you've always got access to this type. So if you want to know if it's something like a tuple or it's actually a tuple, just run this and see what you're going to get. So let's run it, and you can see that it tells me that each one is a tuple, okay? Now there's something else in Python that you need to know, and that's called destructuring. And let's talk about this for a second. So this right now looks a bit messy. We're saying EL0 and then EL1. We can use something called destructuring to clean this up and come up with something that's much cleaner. So let's try to demonstrate this first pretty quick. If I have a tuple, so I'm going to create a tuple of 2 items. Let's say that the first item is just name. So I'm trying to replicate what we've got in a dictionary, and then string Joe. So we've got our tuple, and we can use this destructuring thing. So I can say A and B equals my tuple. So this syntax means that the A is going to be the first element, and then this B is going to be the second element of the tuple. And you can do the same thing with lists as well, and you can put in as many items as you want. So A, B, C. So 3 items. And then a list of maybe a few items, so this one, and then this number, and a floating point number maybe. And now A is that string, B is this number, and C is our floating point number. You can also do it with sets, but if you do that, there's no order, so B is not guaranteed to be the second item that you see on the screen. B could be anything else. B could be maybe the first item that you see or the last item. But it also works, and this is a really common pattern in Python, and actually in a lot of languages, not just Python. And you're going to see it a lot and use it a lot, and it's going to help you clean up your code by a lot. So I want you to think about this for a second and try to clean this code up a little bit and use destructuring so that we end up with something that's cleaner. See how we can do it. Again, remember we've got our tuple, and you can now destructure. So go ahead and do it. And instead of using indexes, just use variable names. So pause it for a second and think about this, and I'll catch you back in a second. All right, so it's pretty easy to do. All you have to do is to say, instead of EL, just key and value, or K and V. Doesn't matter what you call it. You're just defining these new named variables. And then here I can pass in that, so key, and then here value. And if I run this code, I get the exact same results. Again, remember, you don't have to call them key. I can call them this one, as long as I use the same thing right here. This one, I can use this. So we're just destructuring. We're defining these new variables. And now I get the exact same results. Now, one last point, you can easily change all these values, not the keys, but the values. And one way of doing it is just by doing this. So reassigning stuff. So I can say name now equals Adam. So I'm changing this value right here, and it's going to work just fine. If I go ahead and run it, it says the key value pair with the key name is now Adam. Now you cannot change the keys, however, because they are mutable. If you want to do that, you have to remove the key value pair first and then create a new one from scratch. So if you want to change this name to maybe full name, you have to add a new element. So full name, maybe Adam, and then just delete the other one. So delete name. Something that you would rarely do, but it's important to know that actually I have to say del my_d and then that. So now we've got full name Adam, and we no longer have that key value per with name. Again, you would rarely do this, but it's important to know that you cannot change the keys because they are mutable, but you have full control over the values. You can reassign them. You can actually go with another type entirely, so you can do something like this. So name equals maybe a list. So anything. You are free to do anything you want in this case. And also, dictionaries are not really specific to Python. They are also called hash tables, and you'll find them in pretty much all the programming languages. Same thing with all the other data structures that we talked about so far, so lists, tuples, and sets. You will mainly find them in other languages as well, especially lists, tuples, and sets. Sometimes you do, sometimes not really, but if you don't find them in another language, you can implement them yourself, or maybe install a library that has that. But in Python, you've got these 4 data structures that you will end up using a lot. Lists, tuples, sets, and dictionaries. And again, none of them is really anything special to Python. There are common data structures that you'll find in the whole world of computing, and it's important to know how you can deal with them. Alright, so before we end this video, let's have two challenges. One a list challenge and another one a dictionary challenge, so that you're sure that you understand them fully. So now let's have our first challenge. This one's a list challenge, and here's what I want you to do. I'm going to give you a list, and I want you to loop through the elements of the list and find a string that says Atom and make it uppercase. And then print the list, and this is how your result should look like. Notice here that the string Atom is completely uppercase. Okay, so we're just going to loop through, find that element, and make it uppercase. And to get this list, you can go into codedev.ca/upcc/c1 to grab the code. So let me show you that pretty quick. So right here in my browser, I'm going to search for codedev.ca/upcc/c1. And this is now going to give me that Python file. So it has been downloaded. And it's called list challenge. And I'm just going to grab the text and put it in a file. So I'm going to just copy this. There's also a chance that you'll see this text in your browser, or it will be downloaded. Either case, it's fine. Just copy the text or put the file right here. I'm just going to create one file and call it list.py. And here I'm going to paste that. So pretty straightforward, nothing too crazy. Just loop through this list, find the string Atom, and make it uppercase. And also don't try to cheat. Don't count its index and then say our list index equals that. I want you to do it dynamically, so this list could change. It could maybe come from a website user or anywhere else, so it could be different. You just have to do it dynamically. So if you see this string Atom with capital A, just change this whole thing into an uppercase Atom, and then print the list. And this should be your end result. And I'm also going to give you a quick hint about how you can do it easily. Right here in my Python REPL, let's create a list with 1, 2, and then string, and then some more string. All right. Now, if you give this list to the enumerate function, so we've got this function in Python, and if you give it a list, here's what's going to happen. It's going to return an iterator for you. So let me save this result to something called I. So I equals enumerate. If I get the type of I, you can see that it says it's an enumerate type, but it's also an iterator. So if I get the dir of I, a quick way to know whether an object that you've got is an iterator or not is to take a look at its dir. And if you see the underscore underscore next underscore underscore, it means that that object is an iterator. What that means is that you can give it to the next function. So next I, this next function is going to make use of this downer method. Again, it's a topic of another video, not right now, but I just want to give you some ideas about it. And then it's going to, as we discussed before, give us one element at a time. So if I run it, it's going to give me this one. If I run it again, it's going to give me the second element. Now this one should give me string, and the other one should give me some string. Okay, some more string. So it's an iterator. Let's save one of them. So el equals next. And now we're at the end. So as you can see, it's given us one item at a time. And each one is a tuple. So type of el is a tuple. The first element of the tuple is the index. And the second element is the actual element of the list. So that's my quick hint to you. Think about how we can make use of this. You have probably already used this enumerate. It's really common. But if you haven't, think of how we can do it right now easily. So it's an iterator, meaning that you can now put it in a for loop. And now you can also do some destructuring because you're getting tuples one at a time. All right, so pause the video right now, give it a shot, and I'll see you back in a minute. All right, hopefully you managed it, and now I'm going to show you my solution. So I'm going to head over to my code editor, and right here in list.py, I'm going to start iterating over my list. So I can say for item in our list, and then here I can say if item is equal to Atom, then maybe make that uppercase. But how can we do it in this case? Now you might be thinking that now you can use maybe the index method to grab the index and then update it, but that's a heavy operation. If I do it that way, so if I say our list dot index of item, and then grab my index, and then say our list I equals this, Well, it's a valid option, and if I now print my list, so print our list, so let's go ahead and run this. So Python list, you can see that we get the correct result. So we are updating our lists. So it's a valid option, but we're doing too many operations. And as a rule of thumb, the less operations that we do, the faster our application. So here we were looping through once, and then right here we're looping through one more time. So this index method is going to loop through all the elements to find that element's index. So if we've got 1,000,000 elements in this list, this is going to loop through all of them, or maybe half of them, but we're talking generally here, so this atom could be anywhere in the list. But on average, that's what happens. And then this one is going to do another 1,000,000 operations to find that index. And also, we've got too much code here, so let's clean this up. Now, we can use that enumerate function that I just gave you as a hint. So enumerate, and then this one is now going to give us an iterator. And every time we call next, it's going to give us a tuple. So this item is now going to be a tuple. But I'm going to destructure it just like that we did right here. Okay, so here we're getting a tuple. And dict.py, and here we're also getting a tuple. The first item is our index, and the next one is our actual item. And now, I say if item equals atom, all that we want to do is to say our list index equals atom, and we no longer need this line right here. And now if I run this, I should get the exact same result, as you can see right here. Now, if you've done it this way, if you just found the item and you said item.upper, this is not valid because the item is not going to be changed, as you probably know, because strings are mutable. So this is not going to work. Even though we are making the string uppercase, we're creating a new string object that has uppercase atom, but we're not doing anything with it. You can see here that I still have atom as lowercase. So we need to do something with this object. We need to save it because it's a new object that has nothing to do with the previous object. So we need to do it this way. Okay. All right, so that's it about our first challenge. And now moving on to our next challenge. This one is a dictionary challenge. And just like before, I'm going to give you a dictionary. And I want you to go through the dictionary. I'm also going to give you a tuple. And then end up with this end result. So let's grab the code. It's going to be easier. So you can grab the code by going into codadev.ca, UPCC, and then C2. So let me show you that pretty quick. So right here in the previous link that you visited, all that you have to do is to just change C1 to C2, and now it's going to give you the code for challenge 2. And it has been downloaded. I'm going to click on keep here, and I'm going to grab the code. The file is called dict challenge. Here's the code. I'm going to copy it. And in my Visual Studio Code, in the dict.py file, I'm going to paste it right here at the bottom. Okay? So here's the challenge. I want you to print that end result. So you have to grab each element in the tuple. You've got a tuple and a dictionary. And then check if that item of the tuple exists as a key object in our dictionary. And if it does exist, just print the result. So say dictionary has key this, and its value is this. Okay, so here we've got the tuple, and then this is how your result should look like. So our dictionary has the key name, and the value of the key is Joe, and then foobar, and then key nothing, its value is none, and so on and so forth. You should get 5 of these logs in your terminal. Right, so pause the video right now and give it a shot. Okay, hopefully you got it right, and now I'm going to show you my solution. So I'm going to start by looping through my tuple. So for item nt, and here I'm going to do a check. I'm going to check if our dictionary dot get item. So if this exists, here's what we're going to do. We're going to do our print. So print, let's print some dividers, and then print. I'm going to put it in a format string and say our dictionary has the key item. And then in a new line, I'm going to print the value of the key is. And now we need to grab the value of the key. So our dictionary we can either do .get, or in this case, I'm going to use this syntax and grab the item, the key value pair with the key item, and then one more divider at the end. I'm just going to copy paste this one. There we go. Okay, let's give it a shot and see if it's going to work. Now, we have a problem with this, but let me explain. So I'm going to run the code, python dict.py. Now, this one is for our previous code. We've got some printing right here. And just so that we have something super clean, let me also comment everything here. So now we've just got the challenge. Let me run it again. All right, so we get name, Joe, foobar, odd thing. But notice that we're not getting one of the key value pairs. And that one is the key nothing with value none. Now think about why this is happening. Here in our if statement, what we are doing, we're saying .get item. So what's going to be replaced here is the value of that thing. So here for this record, or even this record, we don't have another random value right here, but if we did, it would be the same thing. So it's going to be ultimately replaced with none when it gets to the nothing key. And then, as you can see here, this code is not going to run because now our value is none. So that's something that you got to be careful about when you're putting things in your if statements. Some of the things will return false. And I've gone ahead and done some of these checks so that you don't have to worry a lot about them. Here I'm going to create a new file. I'm going to call it false.py. And I'm just going to paste that code. There we go. So none of these lines will run because all these items that I have put in the if statements are all falsy values. If I go ahead and run this, python false.py, I don't get any logs whatsoever. So if you say if false, super intuitive, it's not going to run. If none, now none in Python is the null value, just means nothing. It's kind of like false, but not quite, just means absolutely nothing. Sometimes for initialization, it could be good to set something to none, and then later on, set an actual value for it. Maybe you're waiting for something to come from your database or an application that's doing some heavy operation. It's going to give you an output. It's going to take you a while to get it, but you still want to have the key. Now, an empty tuple is also false. I'm using the constructor, but if I were to do it this way, it would still be the same thing. 0 is also false. Empty string, empty list, an empty dictionary, and also an empty set. So all of these items are false. If you put them in your if statement, you're not going to get into the block. And here's the complete list that you need to worry about right now. And yeah, that's pretty much it. So you could do some things like this. If I have a list of a few items, 1, 2, 3, and 4, we can loop through all the items and then pop each item out. So what we can do is to say while list. So while list is true, we just want to print list.pop. So what we're doing right now is that we're removing one item at a time from our list and then just printing it. And then we say while list is true, just keep on doing it. What do you think is going to happen if I run it? Do you think we're going to get an error, or do you think we're just going to get all the values and it's going to quit correctly? Again, go back to the concepts. Know that we've got this list right here. So I think it's pretty intuitive. But let's run it. So I'm going to say python false.py. You can see that I got 4, 3, 2, 1, and then it exited. So the first one, the list is going to have 1, 2, 3. So the 4 is going to be popped, and then 3 is going to be popped, 2 is going to be popped, and once 2 is popped, we're going to end up with a list that has only 1 in it. Okay? And now in the final run, we're going to pop this 1 again. So we're going to pop the last item. That's what this pop does. It's going to remove the last item and return it. And then we're going to end up with an empty list. This empty list is going to be put right here. And because this is now a falsy value, we're not going to get to the block and it's going to quit. All right. Now I'm going to give you all these codes that I've written, this one and custom hash at the end of the video. So I'm going to give you a GitHub repo, but don't worry about it right now. So that's what's happening right now in our dict.py. For this one, we're getting none and we're not going to get into the block. So how can we fix this? Pretty easy. Let me actually put a comment right here and say we're not getting the nothing. And let's do it again. So I'm going to copy it, I'm going to comment it, paste it right here. And now instead of doing the if statements, say our dictionary.get that. I'm just going to say if item in our dictionary dot keys. And then all the rest will be just like before. So now this one is going to give us all the elements. Let's run it. Python dict.py. And now we get all the elements. We get the key nothing as well. So remember the syntax. It's really common in Python. This in keyword. So for something, in something, and if something, in something. And the thing that you put right here after in has to be an iterable object. Okay, and you know what an iterable object is. It's an object that you can give to the iter function, and it's going to give you an iterator. And then you can pass the iterator to the next function to keep on getting the next element. Alright, so that's it about our final challenge of this video. And we are now done with this video. We explored a lot of concepts, and now you should feel more confident using Python to develop applications. You should now understand that everything in Python is just an object, and also how we can deal with those objects. Remember, you've got these three important functions, type, dir, and id, that you can make use of to investigate Python objects and figure out what is going on if you're dealing with a bug or something. You should also understand the different characteristics that a Python object could have. An object could be either mutable or immutable, or an object could be hashable or non-hashable, and an object could also be iterable or non-iterable. You should also understand what all those mean. And with that knowledge in place, you are now ready to keep improving your Python skills and keep moving forward. And also, all the code that we wrote in this video is hosted on GitHub, and you can grab the link from the description box down below. Alright, thank you very much, and I'll see you in the next one.